Hello everyone. So this is a question from JEE Mains 2026 28 Jan morning. In period 4 of periodic table, elements with highest and lowest atomic radii are, so we have rubidium and bromine, sodium and chlorine, potassium and bromine, potassium and selenium, and the chapters involved is periodic properties. The period 4 involves, so it starts from potassium. Then we have calcium, then scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Then we have gallium, germanium, arsenic, selenium, bromine, and krypton. Right. So these two are group 1 and group 2 S block. These are the D block elements, and these are our P block, and this is I'm talking about period 4. Okay, so in the question they are talking about elements with highest and lowest atomic radii. So this word is important for us, that is atomic radii. So atomic radius is the distance from the center of the nucleus to the point up to which the density of the electron cloud, or you can say the probability of finding an electron, is maximum. Okay, so atomic radii, distance from center of nucleus to point up to which the density of the electron cloud. Electron cloud is a rough estimation of probability of electrons, right? Up to which the density of the electron cloud, or probability of finding electron, is maximum. So that is known as our atomic radii. And depending upon whether the element is a non-metal or a metal, we have three different kinds of atomic radii. Okay, we have, so depending upon whether the element is a metal or a non-metal, we have three different kinds of atomic radii, and those three are covalent radius, then we have van der Waals radius, and the last one is metallic radius. Right. So not going into much detail about what are these individually. Instead, I will give you a pictorial representation. So covalent radius is, the radius in the covalent when the bond is covalent. So obviously there is going to be overlapping. So this distance, half of, let us say this is D. So D by 2, or half of it, that is this distance, that is D by 2, that is known as covalent radius. Van der Waals radius is when they are bonded, yes, but it is between atoms which are non-bonded to each other. Okay, so let us say, for example, in this case, for example, let's say this is the nucleus of these, and covalent and van der Waals radius will be this. So this is the internuclear distance in the non-bonded state, and half of this, that is this distance, will be the van der Waals radius when they are not bonded to each other. Okay, so this is going to be the van der Waals radius. Okay, and then the last one is metallic radius. So obviously this is in the metallic state. In the metallic state, we have positive ions or kernels, and metals are very close to each other, and obviously we have a sea of valence electrons moving around. So in the metallic state, this is the metallic radius. Okay, so obviously the first two, that is covalent radius and the van der Waals radius, this is for non-metals, and the metallic radius is for metals. Okay, next we will talk about variation of atomic radii in the periodic table, obviously in a period, along the period. Okay, and one thing that is important is this atomic radii, since it is of three types. Okay, it is important to specify which atomic radii I'm talking about. So I'm talking about the covalent radii. Okay, so along the period, the covalent radii decreases with increase in atomic number as we move from left to right in a period. Okay, that is covalent radii decreases with increase in atomic number Z as we move from left to right in a period. Okay, so therefore the alkali metals, that is, they are in the extreme left of the periodic table, so they will have the largest size in a period. Okay, that is alkali metals, that is group 1, these guys are on the extreme left, so they will have the largest size in a period. So therefore you can see in our group, sorry, in period 4, this guy potassium will have the largest size, covalent radii. Okay, and halogens, that is group 17, they will have extreme, I mean they are located at extreme right of the periodic table, they will have the smallest size. Okay, halogens, extreme right of periodic table, so they will be having the smallest size. Important again that I am talking about covalent radii. Okay, so therefore these guys, that is bromine, in period 4, since it belongs to halogens, will have the smallest covalent radii. Okay, now we would want to know the reason why that happens. Okay, why is covalent radii decreasing from potassium to bromine? In between there might be some exceptions or variations, but in a nutshell it does decrease from potassium to bromine. Okay, so the reason is, from left to right in a period, nuclear charge increases by 1 unit, but number of shells remains the same. Okay, so what happens is nuclear charge increase by 1 unit because atomic number is increasing, but number of shells same. Okay, now since you are increasing the nuclear charge, that is the number of protons are increasing, so this will lead to enhanced nuclear charge, due to which the power of the nucleus will increase and electrons of all the shells will be pulled little closer to nucleus, and they will make each individual shell smaller and smaller. Okay, so the number of shells are going to be same, and because of nuclear charge increase, what's going to happen in the nucleus, the number of protons are increasing, and since protons are increasing, what will happen, the power of the nucleus increases, which is basically the enhanced nuclear charge, due to which what will this nucleus do, it will pull the electrons, let's say they are in in a particular shell, and we are increasing these electrons in a particular shell. So what will this nucleus do, it will pull these electrons even more tightly, because as we go along the period, the number of protons are increasing, so this will pull them even more effectively, due to which the size reduces as we go from left to right. Okay, it makes the individual shell smaller and smaller, and therefore the atomic radius decreases from left to right in a period. Okay, so therefore the answer will be, as you can see, this will have, potassium will have maximum size, bromine will have minimum size. Okay, and when we talk about van der Waals radius, then krypton has the maximum van der Waals radius, inert gases will have the maximum van der Waals radius. Okay, so here the options are rubidium bromine not possible, sodium chlorine not possible, potassium and bromine. So this will be the correct answer. Okay, so the answer is C.